Hello everyone and welcome to another live Unity training. My name is Mike Geig and I hope you're all having a fantastic day. Before we get started here, as always, I would like to say that if you have any Unity questions, comments, concerns, if you have any particularly good recipes for chicken noodle soup, feel free to hit us up on Twitter. You can follow us at Unity3D, at The Ant Ranch, at Will Goldstone, at Matt Mirrorfish, and at Mike Geig, which is me. Okay, so today you may have noticed, based on the title of the video and everything, today is our Unity Tips and Tricks grab bag. Had a bit of a Halloween theme for this one, so we're going to just be covering some things you may know about Unity, some things you may not. So strap on in, we're going to go ahead and look at a bunch of stuff. Now, in all fairness, I do want to mention that the idea for today's session and a lot of the stuff inside came from one of our evangelists over in Europe. His name's Andy Touch, so figured I'd do a quick salute to Andy Touch there with a little picture of Andy Touch. A lot of people don't know, but he is one of our amazing evangelists over there. So, Andy, if you ever happen to watch this, which you probably will because I'm going to tell you I'm doing this, yeah, thanks, appreciate it, and I'm sure everyone else will appreciate it as well. So, okay, so today, so we're going to do these tips and tricks. I've rambled on long enough, and so let's go ahead and get started. So the first thing that we want to kind of look at is something that happens a lot, is how to kind of modularize our assets. A lot of times what we'll have is we'll have a project and we'll go and we'll download something from the asset store and it'll sort of get put into our project and we'll have no idea where it went or what it is, or maybe we'll have a full project and we want to pull a piece out of that to use in a different project, and then you're trying to remember what scripts it's using and this and that and the next, and that could be kind of a pain. So let's look at how we can simply create modular packages to use in all of our projects. And I do want to preface by saying that we really should never download from the asset store or anywhere else raw assets directly into a production project. So what I have here is I have a project simply titled Construct. I always create sort of an empty project to sift through stuff. And what I've done here is I've gone to the asset store and I've downloaded the tanks tutorial project, right? So this is from Unite this year. It's pretty awesome. If you haven't checked it out, definitely check it out. It's super cool. All right, and so I've downloaded this, and what we can see here in the project view is the result of that. And there's a lot of stuff. And what we'll also notice is that all of that stuff is directly under assets. So if I had, say, another project, maybe I'm building a project and I just wanted to use some of the tank stuff, and I imported this project, all of our folders are going to be mixed together. And there's no way to say, okay, which assets came from the original package versus which assets came from this new package. So we never really want to import stuff directly into our production scenes. So I always like to create a project, an empty one that I call construct or whatever. And here I've just imported these, and there's a two-phase process to this, all right? So what we're going to do is we're actually going to create this package, and then we're going to refine this package. So right now we have all of the stuff of the entire game. Right, all the different models and assets, and what I want to do is I want to extract a tank. I want to extract the tank for future use. And so I can look in the prefabs folder, but I'm going to notice there's no tank here because the way this particular project was organized is that if I come to the complete folder, there's a prefabs folder in here, and here's the complete tank. So this is what I want, this tank here. By the way, here's a quick tip for you. If you ever want a bigger preview window, you can just right-click on the bar right here. It pops out into its own window, and then you can just put it wherever you want. Yeah. And then if you just close this, it just pops right back down there. So just an FYI, throwing that out there for you. But what I want is this tank. And so the first thing I'm going to do is I'm going to go ahead and I'm going to right-click on this completed tank prefab, right? I'm going to right click and I'm going to select export package, and I'm just going to click on the tank. I'm not going to click on the models and materials or anything like that, just the tank itself. So I'm going to click on that and I'm going to select export package, and it's going to say, hey, what do you want to export? And what I want to be sure of is that include dependencies is checked. Now what we're going to see is this is going to include way more stuff than we actually need. It's just going to include everything that could potentially be related. All right, so I'm going to check include dependencies, and I'm going to click export, and it's going to say, hey, where do you want to save this? And I have this folder which is just live training with the stuff we're going to be doing today, and I'm just going to call this tank. All right, and it's going to export this. Cool, there's my tank. All right, and so now what I'm going to do is, now that I have this package, I want to refine it. And I want to refine it sort of in a vacuum. I could try going about refining here in this project by moving folders around and stuff, but there's so much stuff in here that I don't want that I really don't want to do that here. So instead, I'm just going to click on my assets. I'm going to highlight all of the assets that are currently in this project, and I'm going to delete them. I've extracted the ones that I want, so I'm just going to empty this out. Now I could just re-import this package, and it would probably be fine. But there's something I personally like to do. I like to close the project, delete the library folder, and then reopen it. That way I'm sure there's no remnants of anything anywhere. So, you know, it's more of a, it's not something you have to do. I just like to do it. So I'm going to go ahead and close Unity here. And what we're going to do is I'm going to go ahead and open up my live training folder here. And right here is my construct project. Right here is the Unity package I just created. All right, and so here's another quick thing I'm going to show you, because I just discovered this morning and I think it's awesome. The construct project here, what I'm going to do is I'm going to right click on it, and look, I've got this open as Unity project, right? This is not something that happens normally. What this is, and let me show you here, is there is a website from a guy named Adam Tuliper. I hope you're saying your last name right, actually, where he talks about how you can create a registry key that will allow you to right click on folders and open them as Unity projects, and they're pretty awesome. For those who need bigger text, that's the URL if you want to check that out. I just installed it this morning and I thought it was super duper cool. So that's adamtuliper.com, and then a bunch of numbers, which is the date, open Unity 5 project with right click.html. So there you go. You can watch the video if you want to slow that down and grab that URL, but pretty awesome. So just wanted to throw that out there because I installed it this morning thinking, hey, I'll try it out. Now I'm just like obsessed with it because it's perfect. So I'm just going to go ahead and reopen the construct project now that I've cleaned out. Oh, actually, didn't clean the library folder yet. I'm sorry. I like to open the project, delete the library folder. And that just, again, probably not necessary. I just like doing it. Personal preferences and whatnot. All right, I've always got to fix my window here as soon as I do that. All right, and so now what I'm going to do is I'm going to go ahead and double click on this tank Unity package, and I'm just going to go ahead and re-import everything that's in it. And now I'm importing these again into an empty project now, so that I can further refine that. Some people had asked for that link in chat, so there you go. I just put the link there in chat. Oh, hello. So Holly has joined our chat. Holly is one of our new super awesome community folks. She's in the Seattle office, so everyone say hello to Holly. Welcome, Holly. Okay, so now I have this project re-imported. Okay, not this project, these assets re-imported, and now I'm going to start refining them. So the very first thing I want to do is I don't want all of these folders directly under assets, because no matter what project I import these into, they're just going to muddle with everything else, and I don't want that. And so I'm going to start by creating a folder, which I'm going to call tank, and everything is going to go into that folder. That way, when I import my tank package, it's going to create a tank folder, and all the tank specific stuff will go in there, and nothing will get mixed, unless you just happen to have a tank folder already in your project, and then you're going to have to deal with that. So now I'm just going to sort of step through all of these. So I'm going to click on audio clips. These are all audio clips that have to do with the tank, so I'm just going to go ahead and drop that folder into my tank folder. Now we have this complete, and I don't want this complete folder here anymore. So what I'm going to do is I'm just going to go through the stuff inside. Audio mixers, I definitely want those, so I'll just drop those there. Prefabs, definitely want those. And scripts, absolutely want those. Now, complete is empty, and I will delete it. Yep, goodbye. Inside, we have this editor folder. That's specifically for image effects, so I don't want that, because I'm not using image effects, neither is the tank. Materials, these are all the materials that we'll need, so I definitely want that. Models, definitely want those. Now we have these scripts, and this is kind of the point where, knowing the project files and kind of exploring a little bit is important. I know that these are all the unfinished scripts because these scripts are all the completed scripts. So I don't need the unfinished scripts, and I'll go ahead and just delete those. Sprites are for the UI, I want those. And then standard assets again are for image effects, which I'm not using, so I'm going to go ahead and delete those. Someone has asked in chat, are there any drawbacks to deleting the library folder? Yes, if you delete the library folder and you are missing the meta files that are part of your project that kind of dictate how things are compiled and how they work with each other, then you're going to lose a whole bunch of work. So if you're missing meta files, don't delete the library. Basically leave the meta files alone. However, if you have all of your meta files and they're not corrupt or ruined in any way, deleting the library is completely fine. You're just going to rebuild it when it opens back up with a clean compiled library. So that's the drawback. Be careful. You have your meta tags. Otherwise, it would be a problem. Okay, and so now I've got this tank folder right here, and it's got all of the stuff that I want. One more thing, or a couple more things I'm going to do. I'm going to go to my prefabs folder. I don't want this complete shell. I don't like that naming, and so I'm just going to remove the words complete here. Again, this is all just sort of a refinement process that is just, everyone's a little bit different. You might like the word complete there, you might not, but we're not going to need those. And I'm going to go to the scripts folder, and I'm going to notice I don't need the camera controls scripts because that has nothing to do with my tank, so I'll delete those. Managers are all about the game, not about the tank, so I'll delete those. And now these dictate the bullet, the tank, and the tank's UI. And I want all of those, so I'm going to leave them just like that. Alright, so at this point, what I'm going to do is I am going to go ahead and, first off, I'm going to go to File and Save Project. I don't need to save my scene, I don't care about my scene, but I do want to save project. And what that's going to do is it's going to save any changes that I may have made to my assets. I know that I haven't, but just in case I accidentally did. And then what I'm going to do is I'm going to go ahead and go to my prefabs folder, and I'm just going to drag one of these tanks in here. Can I see it? Yeah, perfect. Alright, and I'm just going to go ahead and hit play. And we'll give this a second here. And there we go, and it's driving around and stuff like that. And I'm able to shoot. Perfect. So this is now a completely modular tank, and I could just export this. However, there's one thing that I know is wrong that's not necessarily apparent, and it just has something to do with the way these assets work. Again, it's super important for you to actually look at your assets. It's something that, I personally believe that no third-party assets, no assets from anywhere, the asset store, your grandma, whoever, no asset comes completely ready to integrate into your project. They all come with some standards or something like that, so it's really up to you to kind of go through assets, fix them, normalize them for your process before exporting them. I have a whole library of packages that I myself use that are a bunch of different things that I have modularized and changed for my own personal uses and then exported them once they were kind of the way I want them. So one of the things I happen to know is there's something wrong with the movement. As a matter of fact, this tank moves with a very special movement axis because of the way it was made for the game, for the tank's game. If I go to Edit and I go to Project Settings and Input, I'll notice that there is no horizontal or vertical axes. There's horizontal UI, vertical UI, horizontal 1, horizontal 2, vertical 2, right? But no horizontal, no vertical. So while this tank works in this project, as soon as I take it into another project and try to drive around with it, I'm going to get an error saying, hey, horizontal 1 and vertical 1 don't exist. So I need to fix that. Another way I can tell, and here's another tip for you, let's say if I look at my tank, and I can see here's my movement script, and these are the public variables, the things that I have access to. Well, what if I wanted to see even the private variables, right? What if I wanted to see everything, which makes diagnosing these problems much simpler? Well, I can do that. What I'm going to do is at the top of my inspector tab here, I'm just going to right click, and I'm going to put it in debug mode. Now in debug mode, if I come down and I look at my tank movement script, I can see my private variables as well. And so if I run this, and I select my tank, I will see under the tank movement script, my movement axis is vertical 1, and my turn axis is horizontal 1. I can see that it's using these non-standard axes, and I can fix it. So I'm just going to go ahead and open up this script, which is tank movement. Let's see here. Someone asked what I meant by the tank's UI. When the tank shoots, a little arrow appears under it and a circle shows its health. That's what I mean by the tank's UI. I'll show you here in a second when I rerun it. So here in Visual Studio, we can see here's all our public variables. In debug mode, I'm able to see those private variables, and we can see those here. And so to fix this, all I'm going to do is come to the start method, and here's where it sets these, all right, based on the actual game design. All I'm going to do is I'm going to comment out the originals. I might even leave myself a little note like this was the original way it's handled and I'm changing it. I'm going to try to keep everything as close to the original as possible, but all I'm going to do is I'm going to remove the player number there, so it's just vertical and horizontal, and then everything is going to continue to work. I could overhaul these scripts if I want, but my goal is to create quick modular packages that I can then further modify in whatever projects I need to. All right, so now that that's done, now I'm done with this tank here. And as a matter of fact, I'll just run it again real quick here. See that ring underneath of it? That's the UI I was talking about. I'm not going to be able to drive it anymore because now it's looking for axes that don't exist in this project. But if I scroll to the tank movement, I can see now I'm dealing with just vertical and horizontal. All right. So I'm going to go ahead now and save my project. That's all done. I'm all happy with that. I'm going to go ahead and leave debug mode in my inspector there because I don't want to stay in that. There's some other stuff that I could screw up there. So not going to spend a lot of time in there. And now I'm going to go ahead and on my tank, I'm going to right click the tank folder. I'm going to right click and export package. Again, leaving everything checked, including all dependencies. I'll export. And I'm just going to override my previous one with this is my new final one. And I'll just hit yes. And now I have a modular final package that I can use in a bunch of different projects and stuff like that. So yeah, nice and easy. Okay, and so that's kind of this sort of tip and trick, just the kind of workflow it takes to refine and make modular these assets. And it's a good thing to get used to and to know, and to just basically the best thing to take away from this is to not import into existing production packages. Always create some empty project to import into, sift through the stuff, pick out the things you want, and then bring those into the project you want. All right, so let me check chat here real quick. Can we export project settings? Yes, you can. As you noted there, that Unity's official projects have project settings. You can export an entire project with those settings and stuff, yes. When the game was run in debug mode, the info box that came up, is that exclusive to Pro version? I don't think so. I'm not going to say absolutely it's available in personal as well, but I'm 99.9% certain that it's available in all versions of Unity. Okay. All right, anyway, so that appears to be all of those questions, so that's good. So now let's look at another sort of project problem that comes up. And this one is, what we're going to do is we're going to build some custom editor stuff. So I'm not going to save this. I don't generally save those scenes. And so now I have this navigation editor. Let's go ahead and pop this open. Again, open in Unity by right-clicking. It's pretty darn cool. Let me just readjust the window size here. My monitor is bigger than 1920 by 1080, so I'm actually not full screen with these windows. So I always have a little bit of adjustment there. Okay. All right, perfect. So what we have, I'm going to go to my scenes folder here, navigation test. So what we have, all right, let's just take a look here, is we have quite a simple project. Here's our tank, by the way, but this is not the tank prefab, though I did make this project after preparing the other one, so I did modularize the tank already, and I'm just using the tank model, so I didn't actually import everything. So just the tank model there. And this tank, all right, has on it a nav mesh agent and a script. And the script is quite simple. Let me just open this up. The script's job is basically just every single update, calculate a new path, all right? And then stop to prevent the tank from actually moving, all right? Normally you'd want the tank to move, but what I'm doing is I'm just calculating a new path. I guess I could call agent.calculatePath, but I wanted to do it this way to sort of simulate us actually calling set destination like we would actually be using it. But I don't want the tank to move. And so the whole purpose of this project is, what I want to do is I want to visualize, I want to see the path that tank is going to take. And once I see the path the tank is going to take, right, I'm going to look at some ways I can enhance that functionality, some of the things that we can do. One of the questions here real quick, is nav meshes for 3D only, or can you use it on 2D? It is 3D only. There are some assets and stuff like that, third-party stuff that have 2D navigation stuff, but the built-in nav meshes are 3D. Okay. And so it's a simple script. All it's doing is making the tank just sort of sit there and calculate paths, which, again, that's not how you would do it in a real game. You don't want to calculate every update cycle because that would be terrible. It's really inefficient. But I'm just doing it to show in real time that pathing. So now I have a plane and a bunch of blocks here, and these are all just static. They don't do anything. They don't have anything special about them. I have this target cube. Again, nothing special about it other than it's green. I have this nav mesh, I have this object called obstacle, which has on it a nav mesh obstacle. All right, this component is what's going to allow it to be non-static so it can move, but still interact with navigation. All right, and for now, I have this thing called carve turned on. I'm going to turn it off for a second here. And now I have this navigation tab, and I'm going to click on that, and you can see that I have a nav mesh already made. Which, in case you don't know how to make nav meshes, all I did was I went to bake here, and I clicked bake. I'll do it again. There you go. That's how easy it is. So I have this nav mesh here, all right? And what I want to do is I want to see the path this tank is going to take as I move this obstacle, and I'd like to see this in real time. Now, you'll see the obstacle here has no apparent effect on the nav mesh. So if the tank wants to come like straight through here, and I move this obstacle in the way, the tank will come here and stop. But it'll keep trying to go forward until I move it, and then it'll go forward. That's not the behavior that I want. That's the default behavior of obstacles. And so that's why originally I have the option carve turned on. What carve is going to do is it's going to say in real time this obstacle can actually affect the nav mesh. If I come back to navigation, now I can see what carve is actually doing to the nav mesh as I move it. All right, it's actually carving out. So if I put the block here, the tank won't stand here and keep trying to get past. The tank will pick a different path, knowing that this is non-passable. All right. I'm sorry, there's a question here. Is there a way to make the nav agent take a varied path to its target destination as opposed to just running straight at it? You can mess with turning angles and things like that, but ultimately the nav mesh agent's job is to go straight at what you're doing in the fastest way possible. All right. Okay, let's see here. Does the size of nav mesh change the resources used in runtime or just processing time to calculate? The nav mesh is very small and simple. It doesn't really add too much to it. The calculations have a bit of weight, which is why you don't want to do them all the time over and over and over again. However, they're much more efficient than, say, a more complex pathing process. So they're really pretty good. Okay. So this is what I have in my scene. I have this nav mesh, I have this obstacle, I have a nav mesh agent that's trying to get to this cube. All right? And what I'd like to do is I'd like to see this path. Now, without doing anything special, without manipulating Unity in any way, I can actually already achieve what I want. So I'm going to hit play. All right? And I'm in game mode here. Obviously, it's not moving. And let me just close the stats there. I'm going to go ahead and do my scene view while the game is still running. And I'm going to, instead of looking at my inspector, I'm going to click back to my navigation tab. So I see my nav mesh, and I'm going to click on my tank. And what I see when I do that is I see the path the tank is going to take right here. And I see it highlight which parts of the nav mesh it's taking. This is default behavior. This is something that it already does. All right? But since I want to see this in real time, and this is showing it to me in real time, but I want to see it in real time as I move this block, this isn't really the solution that's going to work, because as soon as I click away from the tank, you'll notice that I lose the path. And so what I ultimately have to do is then move the block, then click back on the tank, make sure I select the tank parent. All right, so there's the new path, and now I'm going to move the block, right? And I'm going to click back on the tank, right? And now I can see it has to go all the way around here. And if I ever click on my inspector to make any changes here, then I lose all of that, and I have to go back to navigation, then I have to make sure my tank is selected. And even though this shows me the path, it's a really heavy workflow. This default behavior is great for me just checking stuff, but if I'm trying to like see the path of the tank as I'm building a level kind of on the fly and placing stuff and seeing how they behave, clicking back and forth and changing and trying to remember where stuff is, that's kind of a pain, and that's not really something that we want to do. All right. So instead, what I'm going to do is I'm going to extend the editor a bit here. And we all know, we've heard maybe custom inspectors or editor extensions, things like that. And we've seen the classic, like, hey, let's give ourselves a custom inspector here. Let's give ourselves a property drawer or something. So let's take it a step further and let's actually achieve some real-time effect that we want. What we want to do is we want to see this path. All right. And so what I'm going to do is all of our editor scripts have to go into a folder called editor. So I'll just right click on assets and go to create folder, which I will call editor. And I'll open this up and I'm going to create a script. So I'll just right click, create C# script, and I'm going to name this character navigation editor. All right. And the reason I chose that name, it's arbitrary. I could have named this whatever I want. The reason I called it Character Navigation Editor is because my tank actually has a script called Character Navigation, and we're eventually going to make it do stuff here. So this script will modify the behavior of this object, right? So it's just the way I named it. And let's reload our project here. So here we go, Character Navigation Editor. Okay. And so what I'd like to do now, all right, is I need to write some code here. So the first thing I'm going to do is, I always like to just remove collections because I'm not using it. This is not a mono behavior, this is an editor. All right, so I'm going to add editor there. And as editor, I'm going to go ahead and remove void and start. And I'm going to add at the top, right, and I can just right click here and I don't remember how to do it in Visual Studio. I'm just going to do using Unity Editor. There we go. You should be able to right click refactor or fix or whatever, but I don't remember how to do that. Okay, so we're making our editor script here. And so we need using editor. And hopefully that font size is big enough. If that's too small, someone let me know, but I do need to fit code in here, so it's going to be a reasonable size. Okay, and so now what we're going to do is we're going to create a function, and this function's job is going to be drawing our lines in the scene view. All right, we're going to actually draw into the scene view using some stuff called gizmos. In case you forgot or didn't know or whatever, gizmos are generally these handles, and this is the scene gizmo, this is a light gizmo. So gizmos are these things that just appear here that enable us to more easily work with stuff. And so I'm going to go ahead and use that class, the gizmo stuff, all right, and I'm going to go ahead and use that to draw some lines. Someone asked what language this is C#. All right. And so what I'm going to do is I'm going to go ahead and create this function, which for me, I'm going to create it as static void, all right, draw lines for nav agent. Again, this name here, it's something I just picked. I'm drawing a lines for a nav agent, so I figured it was, clever. Okay. And what I'm going to pass into it, oops, don't type while you have stuff highlighted. What I'm going to pass into this is first off a nav mesh agent. All right, this is the thing that I'm modifying, right? And this can be changed. This is a generic function, so I could pass whatever I want in there. All right, so I'm going to be modifying a nav mesh agent, and I'm going to be passing in something called a gizmo type. All right, which I'm just going to call gizmo type. And this function now is going to be responsible for drawing. Now, there's nothing that I've written here that's special in any way. Nothing in here does anything yet. This is just a function. This is me declaring a function. This doesn't make the Unity editor do anything. Unity doesn't recognize this as anything special. I've not done anything cool yet. So what I'm going to do now is I'm going to go ahead and tell Unity, or basically tell the code, that this is an important function that does something very specific. And I'm going to do that with an attribute right above it. All right. So the attribute that I want is I want the attribute draw gizmo. Okay. That's going to say, hey, this function draws a gizmo. And that's where I get things like my gizmo type. And hey, what kind of gizmo are you drawing? Oh, you're drawing one for nav mesh agents, okay? So draw gizmo is what we want here. And now I need to say, hey, which gizmos do I want? All right? When do I want these gizmos? And so I'm going to put some parentheses in here because I need to specify that. And so the first gizmo type says gizmo type.selected. So what this says is when I click on the tank, this function is going to draw gizmos for that tank if it has a nav mesh agent. Basically, if I click on anything that has a nav mesh agent, this is going to draw these lines. This function is going to run. All right? Anything that has a nav mesh agent. Later, we're going to refine that a bit. But remember that I want to not have my tank selected. I want to be able to click on my wall and move my wall around with the tank not selected and still see the line, see the gizmos, right? See the path. And so I'm going to say draw gizmo, gizmo type.selected. I'm also going to say or gizmo type.non-selected. All right, so whether I have the tank selected or not, it's going to draw gizmos if it has a nav mesh agent. Anything with a nav mesh agent is going to have the path drawn if I have, or whether if it has a nav mesh agent, whether it's selected or not. All right. And so now what I'm going to do, all right, I have that there. What I'm going to say is, first and foremost, I have to say if agent, right, my nav mesh agent right here. So if the object has a nav mesh agent, this is going to run. I don't need to check to see if the nav mesh agent is there. This won't run if it's not. But I need to know if there's a path. If there's no path yet, right, maybe this hasn't calculated a path, then obviously there's nothing for me to draw. So I'm going to say basically if agent.path equals null. If it has no path, I'm going to get out of here. All right, I'm not doing anything if there's no path. Now it's time that I actually draw. And normally Gizmos draw is white. That's not going to be very good in my scene. So I am going to say gizmos.color equals color.red. That should make it visible. And now I'm going to actually step through and draw this path. And so I'm going to create an array of vector 3s, so an array of points, and we're going to draw a line from point to point. Now, I do want to point out real quick here that there's a lot of ways I could do this besides this editor script. I really should have said this before, but I'm going to say it now. I could have a line renderer on the tank, and that line renderer could render out its path. That's completely fine. The problem with that is that I'm putting components on this tank. I'm putting things on this tank that I don't need in production. I need for testing. I need for debugging. So I'm adding components to the tank that I don't actually want. I'll later have to remove them. I could put code inside the tank's character navigation script, right, which basically was platform defined. So hey, are you in the editor? If you're in the editor, run this code. But again, what I'm doing is I'm adding code into a production code file that sure won't work, won't be there if I'm not in the editor, but it's going to clutter up that file, and it could lead to maintenance issues. And it basically they're coupled together, and they really prevent this functionality from happening on other stuff. I would need to put this functionality in everything that had a nav mesh agent, right, if I wanted it to happen on more than just one object. And so it's no good. This way, we keep the code that renders this path completely away from everything else. The tank, its own navigation script, its own nav mesh, has no idea this code exists. And so in production time, when I send this out, this code is nowhere to be found. It's not even commented out in another file. It's just not there, right? So this allows us to keep things nice and neat and just sort of and whatever, all right? Okay, so gizmos.color.red, and so we're going to create our path. So sorry, I should have said that before, but I'm saying it now. And so what we're going to do is we're just going to create a path, which I'm going to call points. These are all the points there. And that's going to be equal to agent.path.corners. These corners are the corners of the nav mesh, that basically how the thing is finding itself, or finding its destination. And now I'm just going to iterate through, and I'm going to go ahead and just draw these. So I'm just going to say for int I equals 0, I is less than, man, I could type, I promise. Points.length. There we go. I++. Doesn't help that I have this microphone right in my face, so it's really hard to see. All right, and so inside here, all I'm going to do is draw a line. And I'm going to draw a line by saying gizmos.drawLine. There we go. And the line I'm going to draw is points sub I is going to be the starting point, and points sub I plus 1. Oops. I plus 1 is going to be the endpoint. Also, one thing that I am not going from 0 to i's less than points.length. I'm actually going less than points.length minus 1. We don't want to render that last point because there is no next point, and this will give us an index out of bounds error. So, yep, I equals 0, I is less than points.length minus 1, I++, and then we're going to draw line points I to I plus 1. All right, and that's going to draw our path. And that's the whole script for now. All right, so whether we have it selected or not, we are going to go ahead and render out the path of a nav mesh agent if it has one. So let me pop back over to Unity now. By virtue of this just existing in this folder here, I don't need to do anything else with it. I'm just going to go ahead and hit play. I'm going to go to my scene, and I can see the path this tank is going to take. Furthermore, I can see the path even if the tank is not selected. All right, it's just being drawn by that script. And as I move this wall, I can see it update the path. And there we go. And I can see, hey, what would it take to make it do something really weird, like that. So we can see it can fit through here, but not through there, so it goes all the way around. And so I can use this to diagnose any odd behaviors, maybe that my players are taking when navigation is moving them around. So yeah, I mean, there we go. So we can see that running there. Real quick here, let me just read over the questions here. Does it matter where you save the code, and is the tank's path random or preset? The code has to be saved in a folder called editor to work because it is an editor extension, and the path is not preset. All I am doing is saying, hey tank, get here however you can, and it's just going to try. And you can see as I block one path, it's going to find another one. And these aren't saved anywhere, it's just calculating that. If I were to move this obstacle here, you can see it's going to do that and whatever. So yeah, it's not predefined anywhere. Okay. Let's see here. Someone says editor scripts are the best part of Unity. I agree. I think that's probably the best part of Unity, is the ability to extend it to do whatever you want. All right. So now, this is going to happen to anything that has a nav mesh agent. If I were to put a nav mesh agent on this block here, I would now start seeing a path, even if I don't want it. And so while it's great to say, hey, anything that has a nav mesh agent, I can have a path to, sometimes I want to be able to turn that off as well. And so what I'm going to do is I'm going to add a button to this character navigation script that's going to turn on whether or not it will visualize. Now I do want to say that I could add it to the nav mesh agent itself, but doing this is going to require me to write a custom inspector, and what that's going to do is this nice formatting and everything we see here, that's going to go away because we already have some custom stuff being done to the inspector here. It's going to overwrite that. I don't really want to do that. I don't really want to mess around with changing how the original components in Unity work, so I'm just going to put it on my own script so I have kind of a bit more control over it. And I'm going to actually be able to do this straight from within this same script. All right? I don't need to create a new script. I could, but I don't need to. And so what I'm going to do is inside this new script here, I'm going to go ahead and make this whole script a custom inspector for one of my data types. And so right above the class, now I'm going to add another attribute, and that attribute is custom editor. And I need to say, hey, what type of custom editor is this? So I'm going to say type of, right? And then inside the parentheses there, the type is character navigation. This is the script type I created. Remember, the script on the tank is character navigation, and that's what I'm putting inside there. So custom editor of anything that has a character navigation script. What this is going to do now is that this is not going to run on things that have nav mesh agents that aren't character navigations, right? And so inside here, what I'm going to do is I need a variable that is going to control whether or not this function does anything. And since this function's static, I'm going to go ahead and make a static variable. So I'm going to create static bool, a boolean, called visualize path. And I'm going to set that equal to false by default. I just want to leave it off to begin with. And here inside draw lines, I'm going to say basically if not visualize path, oops, or you don't have a path. So basically if I don't want you to draw the path or you don't have a path, we don't get a path. And so now, based on whether or not I check this or uncheck it, we may or may not see the path. Now what we need is a way to set this value, and this is where we're going to write our custom inspector. And so the custom inspector, it sounds scary, like, oh, I'm going to write a custom inspector, but it really is quite simple. What I'm going to do is there's one function that I'm going to need to use. It's a built-in function. It's public override void on inspector GUI. All right, and then so public override on inspector GUI. I'm not going to use this base on inspector GUI. Instead, I'm going to say draw default inspector. There we go. We're just going to get default printouts there. And then I'm just going to add the checkbox that lets me set this value. And so I'm going to say the value of visualize path is equal to editor GUI layout. All right, dot toggle. All right, and the name of my toggle is going to say visualize path. That's what the name is going to appear in the inspector, and its value is the current value of visualize path. So it'll either be true or false, depending. And there we go. That's our custom inspector. Edits that script has this function here that just toggles this value, which determines whether or not we draw our line. All right. So that's all saved. Let's just pop back over to Unity. And I'm just going to go ahead and hit play. And I'm going to notice in my scene view, no line. All right. However, I now have this variable, visualize path. I check that, I get my line. Let's say I move my block in the way. There's my new line. Maybe I don't want to see it anymore. Uncheck it. There we go. So I control whether or not I see that. And the cool thing is this variable is not in this script. The script has no idea that exists. So there's nothing to remove or comment out when it goes to production, right? My editor has extended it and added that for me, all right? So yeah, super awesome stuff, super useful stuff. I am going to have to go quick because there is one more thing I want to show you. Let me just look through questions here real quick. Let's see here. Someone does say, why does the draw gizmo function use only a single OR as opposed to everything else which uses a double? This actually, this is not OR. This is OR. A lot of people don't know this. This is called short circuit OR. It's a special type of OR and that most people use. But this does not do the same thing as this. This says OR. This says OR with a short circuit saying if this is true, we don't even evaluate the second one. We just bounce right out. Anyway, look that one up, but that's what that is. Okay. Right. Let's see. Yeah, some people already mentioned it there in the chat. Okay, that appears to be the only question that I saw. Now people are talking about visual scripting. So visual scripting is cool. However, it's really, really hard to do production stuff with it. Okay. All right. And so now let's go ahead. So a question here. So why not just put it on the script itself instead of writing a whole inspector for this? We don't want this code muddling up our production code. We want to keep them separate because this doesn't work on device in an actual build. And so I don't want any remnants of this appearing anywhere else. So this keeps them separate and clean. So my actual production code, production objects have no components, have no script, have no anything that I need to remove or comment out or disable or anything like that. Okay. Let's see. All right, that appears to be enough for chat there. Okay, so one last thing we're going to look at. Running out of time here. Hopefully this is so far proving to be useful for everyone. So I have this project. I'm struggling with my words. This project here, I will open as a Unity project. I love that thing. All right, so let's just go ahead and make sure my window fits. And so a lot of people, when I asked what stuff they were interested in, a lot of people said, I got that weird error there. A lot of people said that they're interested in mobile stuff. They're interested in optimization. And here's a good one a lot of people don't know about, and it's super duper cool. So what I'm going to do is let me just pop open this the screen here. And so a very common thing to happen in a 2D game or even a 3D game or whatever is when you open up a chest or you open up some package or something, objects fly out, coins fly everywhere, and you gotta go pick them up. Or, you know, remember Sonic when you got hit by an enemy and your rings flew out and bounced around. You gotta pick them back up, and basically all of these things just kind of appear. Or you know, games almost like a Space Invaders or a Defender or whatever, where these enemies are coming down at you and you're shooting up at them. And basically, any time you have redundant behavior, anytime you have specialized, non-specialized, very generic objects, generic enemies, basically a lot of the same things, right? You run into serious performance hits that you can very easily optimize. And so let's take a look at this here. So I have a scene right now, all right, and if I hit run, there's this Yeti and he's just running back and forth. There's nothing spectacular about this. Yeti, running, cool, whatever. All right, so he's just running back and forth. And I have this emitter, which I'll talk about in a second. And this emitter's job is to create these coins. And let me just put a couple in the scene here. These coins are just prefabs. They're sprites. They have an animation on them, so they'll animate flipping, and they have a collider on them, and a rigid body, and this coin script, which basically says, hey, after 5 seconds, if you haven't picked them up, they just go away. Now, what we're going to do is we're going to look for benchmarking as far as performance goes. So I am not instantiating or destroying anything. This is all pooled. I want to make sure I'm seeing actual behaviors instead of just, oh, hey, I instantiated a bunch of stuff and that killed me for garbage collection. So none of that stuff is happening, right? So I'm going to hit play, and there's the coins. They're going to bounce. The guy picks them up. There we go. All right. So this is 2 coins, and that's something we could possibly see in a game, some coins. But what if we want to have a lot of coins? So I took this idea and I took it to a complete extreme. Let's say we have a treasure chest. Let me delete these coins here. Let's say we have a treasure chest, in this case our emitter, which will create 300 coins a second with a maximum of 1,400 coins alive at any point. All right? And that's a bit of an extreme example. But I figured, hey, let's see how this performs on mobile. Now, you won't be able to see me actually run this on mobile, but I have built this to a device. I have a Galaxy S6 Edge as my Android test device, and 300 of these a second, with a cap of 1,400 total, runs at about 15 frames a second on that device. And let's just hit play. We'll take a look at the script here in a second. But this is what 300 coins a second looks like. All right, that's a lot of coins. All right, yeah, hustling. Get that money, yo. And while we're here, let's just take a look at a profiler. And normally we have a VSync on here. And so we can see that this is running at 60 frames a second, which we can see up here. That's with VSync on, all right, visual sync there. If I turn VSync off, we'll just see the actual what's happening. And I can see that my game kind of runs between 60 frames a second, dips as low as 200. So it's varying between 60 and 200 depending on where in the cycle we are of this Yeti picking up coins. Obviously, when he's picking up all the coins, it's not rendering as many coins. And so, yeah, so we can see it kind of has this wave pattern to it. And you can see most of my performance is orange. And if I look over here, I can see orange is physics. So the physics of this, each of these having a rigid body, each of these having a collider, being an object I can interact with, it's very heavy. All right. Oh, by the way, these coins are set up so they can't collide with each other. All right. So the coins themselves are on a special coin layer. And in physics, I just say, by the way, if you don't know, you can do this. I went to Edit, Project Settings, Physics 2D, and I just said, hey, coins cannot collide with other coins. Right. So I don't have to worry about that. So, yeah, there we go. This runs about 15 frames a second on Android, and I can see while it runs, it's a full 60 frames a second in the editor. Without VSync, this is running between 60 and 200 frames a second. All right. For the sake of covering everything, let's just pop this emitter script open. It's already done. It's pretty straightforward. What it does is it starts by creating whatever my max coins is, right? In this case, 1,400. It creates 1,400 coins and sets them all to non-active, disables all of them. All right. Then inside fixed update, it goes and it active, or basically again sets one to disabled, sets it not to active, moves it to the emitter position, gives it no rotation, so quaternion dot identity, turns it on, and just spits out some random velocity. So it shoots with a velocity upward, a positive y velocity of 10 units, and then -2 to 2, some variance left and right. So it basically makes it a cone or a fan shape, right? It's flying up and a little bit left, a little bit right. All right, and that sets its velocity, and then off it goes. And if we've hit our max coins, we just cycle back around. So if we run out of live coins, we'll start using coins that are already, back at the beginning of the array. So here's another tip for you, and this happens a lot. Let's say you want something that happens a lot. In this case, I want to emit 300 coins a second. What that means is I can't do this inside update, nor can I do this inside fixed update, right? Because fixed update only runs 50 times a second, and at our best, update was only running 200 times a second. So if I try to generate even 1 coin per update frame, I would only get 200 coins a second. So in order to get 300 coins a second, all I do is I say, hey, how many coins a second do I want? In this case, rate, which is 300. I've set that in the inspector. and then just say, hey, okay, rate times how many times we have an update a second. So in this case, fixed update runs 50 times a second, or 0.02 seconds, or 2 milliseconds. So rate times our how many times fixed update is going to run per second, gives us an amount per update, and then we just generate that many coins for every frame. So basically what that does is that's going to give us 300 coins a second. All right, so we just basically do groups of them spread out over a course of 1 second. And that's what we see here. So in summation, we are creating 300 coins, a maximum of 1,400 coins. We're getting 60 frames a second on my PC, 15 frames a second on my phone. All right, we can see physics is kind of our big hog there. Okay, so that's one way to do this. Let's look at another way. All right, we will notice that these coins are pretty repetitive, right? They really don't need to be objects, right? We can actually fake everything that's happening here to get it to function exactly the same way, right? And the user would never ever know. And we can do that using particles. So what I'm going to do is I'm going to just stop that there. And then I'm going to go ahead and someone said in chat just now, why wouldn't you use particles? Well, we are. Perfect. So let's see here. I'm going to go ahead and open method 2. And method 2 still has the Yeti running around, yay. And it has emitter is now just empty. It actually just holds this other particle system thing, all right? And so now we're no longer using sprites, right? These coin sprites. Instead, I have a particle called coin that is this here. And so I'm going to use this particle system. And so if I look at the particle system, it has a script on here. I'm going to disable the script for a second. So what we have here is we've got this particle system just spitting out coins. I can see a few things that are going to make this equal. So first off, it has a start speed of 10. Remember that the vertical velocity of the other coins was 10, so now they're going to be the same. You remember the other coins lived for 5 seconds unless they were picked up. Well, these live for 5 seconds, all right? The other coins could have 1,400 of them max. These can have 1,400 max. The other coins emitted 300 a second. These emit 300 a second, all right? The other ones had this left and right variance. These have left and right variance of the exact same amount, all right? If I look down at the renderer, I can see that I have a custom particle here, and it's an animated particle. So we still see the coin flip, just like we did with our other sprites, right? So we see the sprite sheet being used, and we've got animated coins. What we don't see is a bounce. What we don't see is, if the player runs into these, nothing happens, So that's obviously something we want to fix. And so, someone in chat, does this guy even know how to code? He has terrible coding habits. I'm sorry, Frank. Feel free to message me and let me know what I'm doing wrong. Anyway, and so let's go ahead and take a look at this particle coin script here. And so I'm going to go pop this open. And so what we're going to do is we're going to fake everything that the real objects we're doing. We are going to fake with this script here. And so what I'm going to do is I have this script right here, and I have, first off, the particle system that I'm using, all right? And then where is the player? We're going to fake physics. We're not going to use real physics, all right? We're going to fake it here. And then I'm going to go ahead and I'm going to know where the player is, so I can do that. And I'm going to fake bouncing too. You remember that, sorry, here we've got ourselves a troll. And so let me just ban the troll. Sorry, troll, you are banned. Okay, I hate doing that. It ruins the flow. Okay, and so what I'm going to do is I'm going to go ahead and fake that bounce. I'm not actually going to physically bounce off the ground. Instead, I'm just going to say, hey, where's my ground? And if I'm lower than that, let me bounce, And so we're basically going to fake all this stuff. Here we have our max particles, and here is where we're going to actually store our whole array of particles, right? Inside start, we're just getting our max particles and we're creating this array. And then here inside update, I'm going to basically say coinsystem.getParticles, and I'm going to pass in this array. So this array at the beginning of update is going to get filled with all of my particles. And then I'm going to iterate through each of those particles, which I know big for loops inside update seems like a no-no, but trust me, this is much, much faster than the other way. And we'll actually take a look at that, all right? And so I'm going to get all of these, and I'm going to iterate through each particle, and I'm going to first say, manage my bounce. I'm going to say, hey, if the Y position is lower than the floor, let's pretend that we actually bounced. And so I'm just going to say, okay, and if we're heading downward, guess what? Now we're heading upward. And if we remember the other coins, right, when they hit, they lost some of their velocity. Well, we're sort of faking that one here too, because we know those are traveling with a velocity of 10, and so when they bounce, we're giving it a velocity of 5, right? If I really wanted this to be exactly the same, and I really should, I just was trying to keep the code simple, I would actually then bounce at 2.5 and then, so on and so forth. So I really should just store what its velocity is and use half of that, but I'm not. So it's not going to be exactly the same because I wanted my code to be a little bit cleaner. Otherwise, basically we're going to set the coin at the floor and let it travel upward. So that's going to give us this bounce. And then I'm going to say, hey, what about colliding with the player so the player can collect the coin? Well, guess what again? We're going to fake that. So what we're going to do is I'm just calculating the distance between the player and this particle. All right, I'm just getting its distance. And if the absolute value of that distance is less than, say, 1.5, that's a magic number. I just like the way it works. I really should expose that in the script. But if its distance is less than that, well, guess what? We've collided. I don't need a collider to tell me that if I'm right on top of another object, I've hit it. And so we're going to remove the coin. And to do that, we just set its lifetime equal to 0. This is where we might say, hey, player, you scored a point or whatever. But we're just faking collision here. And then when we're done, we just put it back in the particle system. We take our coins, we say, there you go, you can have them back. Here it goes. Let's see here. One of the questions someone is asking about, GamesMath say, why not use a for each? For each does allocations, which causes garbage collection spikes, which is not good. So do not use that. That's a tip for you right there. Don't ever use for each. If you can avoid it, it's not good. Yeah. Someone else said, why not just enable the collisions of the particles themselves? Because we can have collision of particles. Remember, physics was the biggest part of our problem. We don't want physics, so let's just turn physics off. We can get the same effect, right, without physics just by doing it ourselves, instead of bringing the whole physics engine into this, which we don't want to do. So by doing this, we don't have physics running at all, right, because we don't need it. And so, yeah, we just would prefer to avoid physics. Turning physics on those particles really does just kind of slow it down and stuff like that. All right. And so let's go back to Unity here. And I'm going to go ahead and turn this script on. And so for me, in this level, I just looked, and my floor was negative 3.2. Right? That's just a value that I noticed right here was the floor. I put in the coin particle system right there, which I just clicked and dragged it onto there. And the Yeti, just clicked and dragged it onto there. So let's see how this performs. So I'll hit play. And so now it's going to behave the same way. Notice we're not going to get the smaller bounces. I really could, but it wouldn't affect it pretty much at all. So I'm having the same behavior. I'm picking up all the coins. But now let's profile this. So look at what we've got here. So we've got a ton of VSync, right? Let me turn VSync off. With VSync off, I'm running at 1,000 frames a second. 1,000 frames a second without VSync versus the 60 to 200 using the other method. Notice physics only is even running at all because I believe I have a collider on the Yeti. Yeah, if I turned that off, that would probably go away. So my biggest hog, weighting is 95% of everything now. Rendering is the second heaviest thing I'm doing at 1.6 to 2%. If I scroll down, I can see rendering here. I can see my memory is pretty stable and no physics. Right? This runs on the Galaxy S6 Edge at 60 frames a second. I imagine it would run faster, but the device caps at 60 frames a second, so there's really no getting faster than that. And so we can see that even if I were to make the behavior of these coins more complex, I have a lot of wiggle room before it's even a fraction of as inefficient as the other method. All right, so what I'm saying is in mobile or just everywhere you can replace redundant objects that behave similarly, that look similarly. We can replace them with particles. These didn't have to be bouncing, moving particles. These could be the enemies in the sky for Space Invaders, right? And as you shoot one of the particles, they just go away, right? There's no reason we have to use game objects like this. Someone said, would linked lists be viable for this pooling method? I'm sure they would. I just know arrays are really fast, so I use that. Someone says, what is weighting and profiler? Right now, Unity by default is set to VSync, so synchronize with the refresh rate of your monitor, which is generally around 60 hertz or 60 frames a second. So what it's doing is it's waiting to render for my monitor to be ready, so you don't see any flicker. So if we want to see what VSync does, it turn VSync on, and you'll see my game is going to run about 60 frames a second. Turning it off, I can see how it runs without it. Let's see here. Can we use this in 3D? Absolutely. Though particles are obviously more visually convincing in 2D since they always face the camera, but there's really no reason you couldn't do this in 3D for simple graphical things. Let's see. Someone said they can't post a link without getting deleted or banned. You won't get banned, but the link won't post. Posting links is not allowed. Let's see. Okay, so these are the things I wanted to show you, right? These are just basic kind of more involved examples of optimizations, tips, tricks, things like that. I'm going to go ahead and let's see, there's quite a few questions in chat there, so I'm going to go ahead and answer those. But yeah, I just kind of wanted to show some things that weren't just your general like tips and tricks. So kind of as a recap, some of the things we've looked at. The first, extracting modular assets, is kind of a two-step phase. Extraction and then refinement is much easier that way. Also, always kind of be mindful of where you're importing assets. Try not to import into production projects, because then that stuff just sort of gets scattered and mixed in with your project. If you ever want to remove it later, it's really hard to do. The next thing is writing editor scripts is awesome. Definitely write editor scripts to customize and enhance your workflow without necessarily needing to write heavy-handed or non-extensible muddy code in with the rest of your stuff where you wouldn't necessarily want it. So yeah, definitely extend the editor and use that really to supplement and enhance your workflow, as opposed to any other weird stuff that you might have to do to make things work, right? The editor is incredibly extensible, so I highly recommend it. Then, if you have repeatable, redundant stuff, things that behave rather simply, or stuff that you can model yourself with code, replace game objects with particles. They're much, much better at drawing, just tons of them. As a matter of fact, on my mobile device, I actually got up to spawning 3,000 coins a second with 8,000 coins maximum before I dropped below 60 frames a second on my phone. So, I mean, you can really push it that way. A couple other small things. If you want that, right-click, open Unity project. That's where I got it from. It's super awesome. Definitely check it out. And pool your objects if you can. If I wanted to kind of prove my point, you can see if I were to turn everything else off, except for, there we go. If I were to turn everything else off, except for garbage collection, I've got nothing, at least in this scene. I forgot that I have two scenes. The other scene is the one that does the pooling. So let me open that up here. Do the same thing. Turn everything off but garbage collection, and you can see again, all these objects used seem to be created, seem to be destroyed. No garbage collection. All right. We have some garbage collection inside our physics. There's nothing we can really do about that. But yeah, so pooling objects, super duper awesome. All right, let me check chat out here real quick. Next time I need a Jolly Yeti to stroll through the sea of coins, I'll think of this video. You'd be amazed how often you just need a Yeti to just roll deep in some coins, right? It happens. Can you recap what the main savings of that was? Just not using physics. Were you instantiating before? No, I was not instantiating before. It was all pooled, but basically physics and moving and tracking actual game objects was just heavy when you're doing 300 of them a second. So by not having game objects, by not having transforms, by not having rigid bodies, by not having colliders, by not having animations, right? All of those things were on one coin object, but not having any of these things, right? Their own renderers, their own animators, by removing all that stuff, it's super fast. Let's see. What song do I listen to daily? Spirit Never Die, my master plan. Look it up, it's amazing. Let's see here. Hi, when we get that, Smart Sprite and other tools. The Smart Sprite and other tools, check the roadmap. I don't want to say something I'm not supposed to. So Smart Sprites, all that cool stuff, check the roadmap. I'm not going to say anything else about it. Let's see. Some asked, do we have live training on visual, live training video on garbage collection? Not really, but we do have stuff on object pools and things like that, which is basically about garbage collection and ways to avoid it. Is the first scene using pooling? Yes, it is using pooling, so pooling would not make it faster. If I was instantiating, that first scene would not run. Instantiating 300 objects a second would be rough. Let's see here. Let's see. How do you test your app on Android? Here's a little tidbit. So to test stuff on Android or iOS for that matter, if you go to File and then Build Settings, and when you build, so I'm already set up for Android right now, you can check Development Build and Auto Connect Profiler. Then when you build and run out to your device and you leave it plugged in to your computer, the profiler will open up and show you it running on the device, and you can see all of the stuff I just saw on the profiler, frames per second. What's this doing? What's that doing? So you can profile on device. It's super awesome. Let's see here. Continuing on. Let's see. All right. Okay, that appears to be... Oh, wait. Created an editor window and I'm using on GUI instead of on inspector GUI. What's the difference? Well, editor windows you would use on GUI. When custom inspectors to overwrite the inspector, you use on inspector GUI. There's a bunch of different editor extension functions, and we have documentation on all of them, and you can see they all have kind of special uses. On inspector GUI is for the inspector, on scene GUI is for rendering directly into the scene, things like that. What would be the smartest way to attach pickup sounds to those coins? I would definitely not put sounds on the coins. I would put sounds on the Yeti. And when the Yeti hit a coin, the Yeti plays the sound. And then there's only one audio source, as opposed to trying to have a potential of 1,400 audio sources, which would be really, really bad. Why isn't Unity written in C++? It is written in C++. You mean why is our scripting not in C++? I'm assuming the question is why are the scripts not C++? This happens a lot. C++ is my favorite language. It is by far my favorite programming language, but I don't want to work in it every day. I like C++. I think it's awesome. It's what I learned with. I still write in it every time I can, but C++ says you have to manage all this stuff, and C# says you can, or you could just not, and I very much prefer the just not. I'm not making any assumptions of your particular programming skills or anything, but what I am of the opinion of is that people who work in C++ every day are not the people who generally want to work in C++ every day. Again, I'm saying that knowing it's my favorite language, but it's really super awesome. But when you shoot yourself in the foot with C++, it's like shooting yourself in the foot with a nuclear bomb. What caused the coins to drop back down after the bounce? On the emitter itself, I'm sorry, I assumed it was visible, but maybe it wasn't. No, it was, yeah. So I have just gravity on it. Gravity's pulling it down, it bounces, gravity begins pulling it down. Yep, gravity's just on it. Okay, at this point we really do need to wrap up because I am just sort of rambling now and just sort of answering random questions. Yeah, and so thank you everyone for listening. Again, there's a Twitter if you want to message us, and really appreciate you sitting in, having another picture of Barney, and have a great day, and thank you all very much.